Hello, this is Keith Owen. Welcome back. Today's tutorial is going to be another tutorial on using Python within Excel. And what we're going to be doing is what you're seeing on the screen here is just a screenshot. This is not operational right at this time, but I'm going to tell you what we're going to be building. And it's basically we're going to hook up a slicer that's created within Excel, and we're going to click on the individual regions. And then as we click on individual regions, this Python bar plot that you see down below will be automatically updated with the data associated with whatever region or regions I select up here. So we're going to dynamically change this title here. These data labels will be automatically updated to reflect whatever region it is. And we're also going to be able to format the y-axis numbers here. And so instead of showing like 2 million or 3 million here, we're going to be showing like 3M. So, and we're also going to be doing the formatting that you see here for the data labels here also. So let's go ahead and go to the next area here. Now what you see here is once we get into the Python code, we're going to be dealing with a figure and an axis. Basically, a figure is like an canvas that we're going to be working with, and then on top of that canvas we're going to be plotting a bar chart. And so that's the difference between a figure and an axis object. So the figure area is what you see here outside on the outside corners here. And what we place on top of the figure is going to be our axis object, which is going to be the bar graph itself. So this gives you a visual of what we're trying to do. And within the Python code, when I say FIG or figure dot something, that means that we're accessing the figure of this area. And if I'm using AX, which stands for access, if I do AX dot something, that means I'm going to be modifying the bar chart itself. So hopefully that gives you a good visual of what we're going to be doing in Python and Excel. So this is the data set that we're going to be working on. It's fictitious data based upon retail sales for a tech company. And it's, as you can see, the column names that we have, the product, the region, units sold, revenue, and all that. And what we're going to be doing is with that bar plot that we're going to be doing, we're going to be segregating by region, okay, and the product. So in other words, we're going to be summing up the revenue for the product by region, and that's what we're going to be doing in the bar graph. So our first step here is let's create an Excel table. So what you do is just select anywhere in your data area, Control T selects your data, and you want to select my table has headers, so it reflects that. Let's just give this a plain format here, okay? And then what we want to do, let's go ahead and name this table up here by selecting Table Design in the ribbon, and we're just going to call it Sales Data. Okay, so our next step is going to be we need to create an helper column. So when we create an Excel slicer, we need a way to hook up that slicer to this data. And a way to do that, because we need to do it in a way that Python understands this. So let's create a helper column. And we're just going to be calling this is visible. Okay. And what we want to do is, because when we filter, let's create this, let's do that. Okay, misspelled it. But what we want to do is when we filter this data, I'll give you an example. Let's click on the filter button and let's unselect all and just select Africa. And as you can see, it just creates uh, uh, data that's filtered by with region as Africa. But if you look over here to the left, you're going to see that you're missing rows. So some rows are going to be visible, some rows are going to be not visible. And what we want to do is when we create a data frame in Python, we always want to be looking at the visible data. And in order to do that is we're going to create this helper column, and we're going to check whether or not a row is visible or not visible. And we do that by using an Excel formula called subtotal. And what we're going to be looking to do is we're going to be looking for the count A function down here, 103. So we're going to double click on that and then comma, and then I'm going to show you the difference what's going to be happening here. Let me put this in at product and then enter. And what it does, it automatically fills down for us. And what it does, it returns a 1 in this column. So if we go ahead and let's just select something here and I'll show you. Okay, you're always going to see 1s in this data set here. And the reason is because it's looking at the filtered data. Uh, uh, and we want to be able to select this data based upon is visible. So let's go ahead and unfilter this. And let's also explain this a little bit further. Now, subtotal performs a calculation, okay, on a filtered range. And 103, if you look up here, the 103, the first argument, is a type of subtotal that we want to compute. And in this instance, it's a count A function, which ignores hidden rows by filtering in this case. Okay, so at product now, okay, this it does this for a single row, and so it returns 1 or 0, and that's what we want. And you'll see this when we get into the Python code. This will be the logic that we will be using when we're creating the Python chart. So now let's, I want to do this a different way. At product means it's calculating this based upon the current row. If I remove at product, press enter, as you can see, the number changes now. The reason why it creates 1000 is because one, let's control down arrow, we have 1000 rows in our data set. Now, if I go ahead and let's say I just want to do this, as you can see, this this changes. The reason why it changes is because I filtered out some rows. And remember, count A in this particular situation counts all visible rows. So that's why we got a different number. But so what we want to do instead for the Python code, we just want to look for whether or not if the row is equal to 1. And that means that the row is filtered and it is showing. And that's what we want in our data set, in our data frame. Let's do this for a single row, enter. Let's change that back. You'll see this more clearly in a second. What we want to do is we wanted to add a slicer to this data set. So we click anywhere in our data, okay, and go up to insert. Over here to the right in the filters group, click on slicer. And what we want to do, it brings up the column names in our data set here. and it gives us the options of what slicer we want to slice this by. In other words, what columns do we want to filter by? In this case, I'm just going to select region, click OK. And what I'm going to do is I already have a pre-formatted slicer. Okay, if I select this, go up to slicer, and if I go over to slicer styles, I already created uh, um, a slicer style for this. So I select my slicer, click up here under slicer styles, and select my custom slicer. So I did that, and now what I want to do is I just want to expand it a little bit and go up to slicer, and I want to increase the columns so they fit all across. Okay, so let's do this. Let's close this up. So now what I want to do is basically watch what happens to this data set when I click right now these dark blue areas. That means all regions are selected. If I just select that one, you will see that Asia just appears in the region column. If I do a control click North America, that means I got both regions selected. And as you can see, the region is changing over here. So which means that this is visible column will only show one when these rows are appearing or filtered down. So now let's go to the next step. And after, again, after the slicer is added, we want to start the Python code. So let's go over here. Let's move this down and let's bring in the Python code. Our first, but first let's go up to here, formulas, initialization. It's important to understand here that what Python does, it typically imports these libraries that you see over here. And if you don't see the library that you need, then we have to do a specific import statement in our Python code over here. So that's what we're going to be doing here, because our what we want to do is we want to be able to uh, 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 do a specific, we're going to access this matplotlib.ticker library. So we're going to do equal Python py, enter in Python mode, and we're going to type in, actually, it's from matplotlib.ticker import func formatter. And this allows us to define a custom function to format our tick labels, basically on our axis in our plot. So I pressed enter. Now, when you create a custom function, it's best that you create the function at the top of your code. So what we're going to do is we're going to define a function, and min, this is what I'm calling it. This is the function name I'm calling it. You call it whatever that you want. And I'm going to pass in 2 arguments. And you're going to learn more about this later once we do make the call. So we want the call in there. Press enter. We need a tab. Return. And what it's going to return is, once we pass in the necessary information, it's going to format it for us. So we're going to use the format string, and then we're going to use the curly braces, x divided by 1 million. And then how we're going to format this this expression here is we want 0 decimal places. Okay. And then we're going to close it out. And then after this expression gets evaluated, we want to make it uh, with an M after it. So I'm just going to press Control Enter. Nothing's going to return at this point, but let's go back to this chart area here. Control page down. And what this is going to do is we're going to be formatting this y-axis here. So when I say we're going to pass in a number, so whatever the value of these tick marks is, let's say it's 12.5 million, that means a whole number would be displayed here. But since we don't have enough room here, we want it displayed as 12 million or 2 million or whatever it may be, meaning 2M. That's what it's going to be doing. So let's go back to our tab here. Okay, let's go back to our code. Now, let's press enter, tab back there, and let's create a custom palette for the bars. If you remember, our bar plot has different colors for each bar on there. So what I'm going to do is I'm just going to copy and paste this code in here so you don't have to watch me type it in. Okay, so I copied it in. Basically, what I'm going to be doing is I'm going to create a variable that holds a list of these hex codes, which are colors. And you can ignore the pound after that. That's just a comment or whatnot. So, and you'll explain more. I'll explain more as we use this going down. Okay, so once we have that, we want to create the data frame. So basically, I'm going to call it data frame underscore dash word. Now that's going to look equal to our data over here. Let's go over here. It selects all the data. Okay. And now I'm just going to press Control Enter. So it created the data frame over here. As you can see, it grabbed all the data and created the data frame for us. Let's continue on with the Python code. Okay. And now we want to get the actual filter data. So when we click on this, it will always look at the filter data instead of the whole data frame itself, instead of all the data in there. So we will always want this to be hooked up to our filtered data that's over here. So we're going to create a separate data frame, and we're just going to call it data frame underscore db underscore visible equal to our main data frame. Okay. And we're going to access this column here. And we're going to check to see if it's equal to 1, our column. So we're going to press enter. So we commit the changes. Okay. And then if we look at this filtered data frame, you could see that it's only picking up North America and Asia, which is what's over here. So let's click out of here. So let's click on Europe. Okay, so as you can see, it still clicks. Um, uh, it's selected Europe and it's filtering it by Europe. If we click on the data frame up here, you could see that the data frame only returns rows with Europe in there. So that's how we hook up the slicer to our data frame. Okay, so now our next step is we want to get a unique value list of our regions selected, and we're going to utilize this unique value list to populate our title within our plot later on. So let's go over here, tab, let's do enter, and then we're going to do selected underscore region. That's going to be equal to our unique from our filtered basically data frame. We're going to access our filtered data frame column called region, and we're going to use dot unique. What this does is it's going to grab all the values in our data frame, and it's going to select basically every time it's filtered, it's going to select the unique values in this region column. So that's what it's going to do, and it's going to create an array for us. And we'll utilize this later on in the code. Now what we want to do is we want to sum up the column, the revenue. So we want to be able to get the total revenue for our filtered regions that we select here. So what we do is we're going to utilize this in the title again later on. We're going to create a variable that holds the total revenue. That's going to equal to data frame underscore db visible. And we're going to access the revenue column. Wait. And let's go back over here. I made mistakes. And then this is going to set that to that. Okay. Press enter. Now we want to create a separate data frame for our grouping. In other words, we want to be able to group by product and region. So we're going to create revenue by product. Okay, and that's going to equal to our data frame underscore db dot group by. We're going to do a group by, and then we're going to be grouping by the product column. Okay, and we're going to set the index to false. Because what we want to do is we want to be able to bring two columns back, one for the product and one for the revenue. And we don't want the product column to be the index in this case because this is going to be utilized for our bar chart. And then we're going to access the revenue column. What do we want to do with the revenue column? We want to sum this up. Dot sum. And then we want to sort the values. And we're going to we're going to pass it in. What column do we want to sort it by? And we want to sort it by revenue. And then we want to do it ascending order. I mean, we want to do it in descending order, basically. So that's why we're putting ascending false. Okay, let's press Control Enter. Give it a second. Okay, there's an error here, so we're going to look at the error first. I might have did a typo. Let's scroll down here. Let's see, key error region. So I misspelled region. So let's go back over here. ION. Let's see if I did everything else. Okay, let's do this. Let's press Control Enter again to commit it, and it did it okay. So now let's click on here. Okay, so this is what we're going to be using. This is the grouped data frame now. So as you can see now, we have an index column, and we have two columns here, product and revenue. So basically this information that you see here is going to be used to generate the individual bars on the bar plot. And as you can see, it's in descending order, which is what we want. So after we do that, now we want to go into creating the bar chart itself. So let's go back into our cell here. Let's press Enter. And we want to use a PLT dot figure. Let's do this right. Okay. And we're going to pass in a figure size of our choice. And it's done by inches. So it's first by width, by height. And if we don't do this, Matplotlib and Seaborn is going to generate a default size for us. So you don't have to do this. We're just doing it to create a certain size bar plot. So now we do AX. Remember what I talked about in the beginning. When I do an AX dot something, that means that we're going to be generating or we're going to be accessing the plot area of the chart, not the figure, but the plot area. So SNS dot bar plot, and we're going to pass in the data frame that we want. Data is equal to revenue by product. And then our X values is going to be equal to our product column in our data frame. And then our Y value is going to be the revenue column. And then we're going to be passing in our custom palette that we created before. So our parameter name is palette equal to custom palette. Let's do that, and then let's press enter. Okay, it created an image for us. So this is the image, and now let's bring it out and display over the cells. A shortcut key is Control Shift Alt C, and let's downsize this a little bit here. Okay, as you can see, this is what it created. Now what we're going to be doing is we're going to be doing a formatting of this chart. Now, as you can see here, it has 6 bars. And let's go over here. Let's do this and give it a second to regenerate. It does the same thing because it has six different products within that region. So let's also do this. We need to format this so it doesn't resize as the data shrinks. So let's go to size and properties, and we're going to go down to properties here, and what we want to do is select don't move in size with cells. Okay, we select that, and now let's go over here. Let's control click. So as you can see, it updated the bar chart, and you'll see this more visibly when we get more when we have the data labels and everything like this. But I want to explain this custom palette here. And what this is doing here, let's go back up to the code. This custom palette, as you can see, it has 6 different values. Now your question is probably, what if we have, 4 bars? What it does, it creates a color scheme starting from this top first one, and it assigns this color for each bar that it returns. If there's less bars than what we have here, it just stops at, in a case where there's only 4 bars, it'll stop here and it'll ignore the rest. If by chance we have more bars than the number of colors within this color custom palette variable, that means it just cycles back up to the top and starts the coloring scheme all over. So that's how that works. So now let's go on to formatting this bar chart itself more. So we're gonna put in some enhancements here. And now let's say we want to ax dot set underscore X label. We want to format the X label, and we're going to call it product, and you'll see the changes once I press Control Enter. We want this product value here to be formatted with a font size of 12, comma, the weight is going to be bold, WEIGHT, equal bold. We want this in quotes. And then we want the color to be, in this case, equal to a hex value of 0B3040. And now let's press Control Enter so you can see the visible changes to it. As you can see, this is what it did. It added an X label, called it product, and we changed the font size and the color size to it. So now what we're gonna be changing is the Y label. So let's go back over here, scroll down, let's copy this. And we're going to change this to Y label. And then we're going to change the wording for it. It's going to be so it signifies revenue. And we're going to keep everything else the same. Control Enter, and you'll see the changes over here. See what it did over here? It created revenue. Okay, and put a $sign. Change the font size, made it bold. So let's go on further here. Now let's format this, these tick marks over here. Okay, so it signifies that it's in millions. So let's go over here, enter. And this is where we're going to be accessing the custom function that we created earlier. So we're going to do AX is equal to PLT dot GCA. Okay. Do that first, press enter, then AX dot Y axis dot set major formatter, and then function formatter, tab into that, and then millions. This is the custom function that we called earlier. Now let's press Control Enter. I might have did a typo, so let's go ahead and look at this. Incomplete input, so let's go back over here. Look at what I did. Okay, the reason why I got that error before, because I misspelled something here. Okay, and the way this is working is I'm calling this, I'm passing a reference to our defined custom function. And as you can see, I'm not passing it any variables. Let's go back up here, right here. So our define function requires two arguments with parameters. And as you can see with our function call, I didn't pass it anything. So what Python does, since I passed in a reference to it, meaning I typed in millions underscore formatter without the opening and closing parens, that means I'm passing on a reference. And then Python, at the time it renders, basically it starts creating these tick marks here on the y-axis. It'll pass in those values for it, and then once it passes in those values here, for each one of these individual tick marks, it's gonna format it in terms of like this, like you see 5M or 4M. So that's how that is working down here. So let's go on to our next step. Let's scroll down here. And let's take a step back. What does GCA stand for? GCA stands for Get Current Access, meaning that we want to do the next step by applying what the current access here is, and that's what that is. And later on, we're going to do something with PLT.GCF, which stands for Get Current Figure, is what we're going to be doing. So let's go on to the next step on formatting this chart here. And once we do this above here, now let's create data labels for the bars. So in other words, we want to know what the values of these individual bars are, and we're going to plot data labels right above them. So we do that by doing this for loop. And what this is doing is it create these containers are referring to basically these individual bars. And within each container contains one to many number of bars in there. So that's why we're looping through each one of these. So that's what that is. AX dot bar label. And tab into that. We're going to pass in the container. Okay. And then press enter again. labels is going to be equal to, this is how we're going to be formatting it. We're going to format it with a list. So F format string, and then we're going to pass in bar dot get underscore height. Okay, and then we're going to divide that value by 1 million. I'll explain this in a second. How are we going to format this value that it generates? And we're going to be doing it with a 0.1, meaning we want 1 decimal point. Okay. F. Let's use a curly brace to close that out. And then we want the letter M. And then 4 bar in container. Tab down there, label, type, edge, and I'll explain what this means once we redisplay this bar chart. Font size is going to be equal to 10. And then we're going to close this out. Press Control Enter. If I don't have any typos, it should generate what we need. And I have a typo somewhere, so let's figure this out. Give me a second. I misspelled something here. Okay, I just misspelled the word containers over here, so I corrected that. So let's walk through this area here. Again, for container in AX. So in other words, this is the axis that we're trying to work with. It has a container that holds the number of bars that we have. And this is dynamic based upon the regions, or I mean, the products within each region. So that's how it generates the number of bars. So within that container, it holds X number of bars. And the bar label function, we're going to pass in the container, the current container object, which we get from here. And then the labels for each one as we loop through it, we're going to format it with this area up here. And what this 4-bar and container means is now we're going to have an individual bar within this whole container that holds all the bars. And this bar.getHeight function, meaning that whatever the value of this sum is for this particular product within these regions selected. So in other words, this is equal to almost 5.5 million. So we're going to take that whole number, 5.5 million, divided by 1 million. You get down to a decimal, which is 5.4. Okay, once we have 5.4, again, we want to bring it down to one decimal place, and we're going to put an M after it. So that's what this is doing. The label type edge, what this means is it's going to take this label and put it on, in this particular case, on the top portion of each bar. So it puts it on the top edge of each one of these bars. And the font size just means that what is the font size of this particular label. So that's what that is doing in a nutshell. Okay, now what we want to do is we want to add some grid lines, okay, to this bar chart. So let's go back in here, formula bar. And now we want to access the grid lines, which is part of the access object, AX dot it's equal to I'm just passing in gray color, and you'll see this in a second visually, comma line is equal to 0.5. And then our line style is what I want to create a dashed line, not a solid line. So that's what I'm doing next, equal to press enter, and then we're going to be doing ax.set underscore access below is true. Again, I must have did a typo. I'm sorry about this, but it happens. As you're coding, you're always going to do some typos. So let's see what the typo is. Y-axis is not defined, so I did a typo up here. Give me a second. Okay, what I want to do is ax dot y-axis dot grid. Let's press Control Enter again. There we go. So as you can see, it put some grid lines. Let's scroll back down to the chart here. It colored it in gray, and you can barely see it, but it is a dashed line. And grid, the first parameter is true. That means that we want to show the grid lines. That's what true stands for. And what this set underscore access below means, it means that we're going to put these grid lines behind the individual bars. So that's what that means here. So now let's go on to the last part, and we're going to be configuring the dynamic titles in here. So again, let's do FIG is equal to PLD dot get current figure. Okay. And now we go fig dot set. Okay. Okay, what I did was I copied and pasted code in here to format the dynamic titles. I did that because so you don't have to sit through me typing all this information here. But basically what I did was I created a new variable called region string, and what that's going to hold is it's going to format this variable by joining it with our selected region values up above here. So let's scroll back up here quickly. And we got, let's see, where is it? Selected regions. So we created a variable that holds an array of the unique region values in our filtered array here. And if I scroll back down here, and what this dot join method does, it concatenates with a string that for each region in this array that we captured up here, we want to, after each unique value, let's say it's Asia, we want to put a comma after it and a space. And then we join it with the next region that appears in this variable. Okay. And then we go on to the figure area and we do a plt.gcf stands for get current figure. And that's going to be held in this variable. And then we're going to set the face color. The face color of the figure is what you see here. It's this off-white blue color. So that's what that is referring to. Now the figure dot subtitle, that stands for super title. And what we want to pass in there is the total revenue product, which is what you see here. It's in the color of this hex value. The font size is 14, which is bigger than the rest of this. And we set the font to be a bold next. And then the ax.setTitle. Now this portion is part of this access object, not the figure, which is what you see on the outer layer of it. But this is the access object that we're referring to. And we got a title here, North America, Asian region, because we have the North American and Asian region selected. So we pass that value in the region string as we format it above here. And then we, after each region, after all the regions have been listed, we're going to have a static value of region, colon, and then we're going to pass in the value of our total revenue variable that we created at the beginning. And we're going to format it with 0 decimal places. So that's what this means here. And then we created a font size of 12, which is smaller, and the color is this. So that's basically how you create a dynamic bar chart for a bar plot in Python in Excel using an Excel slicer. So let's test this out. Let's just select Africa. And so as you can see, it dynamically changes. Let's go over here, select Europe, and it dynamically changes for the values, Europe, whatnot. So region, it's 14,000. So in other words, this number is calculated by taking the total revenue of this column here in our filtered data set or data frame. So that's where this value comes up with. Let's just let's just get rid of the filters and have all the regions selected. As you can see, it populates the title up here with all the regions selected, and 63 is the total revenue for all regions. So if I do a control shift down, control backspace, as you can see in the sum in the status bar in Excel, we have 63,032, and that matches with the value that's here. So again, I want to thank you for stopping by. I know these tutorials are quite long, but I find it necessary to walk through the code so you understand how we could generate all this stuff within using Python within Excel. And I'll do a lot more tutorials in the future on how we could create stuff like this. Again, I want to thank you for stopping by. And if you missed last week's video, please watch that. And I've also created a playlist called Python in Excel. And then you can watch all tutorials that I place in there also. Again, thanks for your time. I look forward to speaking next time on our next video. Remember to subscribe and please like and share because it helps this video to get out to more people. Thanks again. I'll talk to you soon.